everyone, in this video we're going to look at some maths problems relating to the theory that we went through in the previous video. So combining linear and geometric sequences, so basically it's not just one or the other, you're combining them, and basically that just means you're making additional payments if we're thinking of context of financial maths. So you've got three types: investment, reducing balance loans, and annuities. And remember, perpetuities is just a type of annuity, and we'll go over that in more detail later. So in this video, we're just going to look at investments and reducing balance loans, and then in a separate video I'm going to do annuities and perpetuities, just because I don't want these videos to be too long. And then, if you only need help with annuities, then you can go straight to that video anyway. All right, so just quickly looking at the different types of recurrence relations. So it does depend on what you're looking at. So if you're looking at an investment, remember V0 is always your principal, might sometimes be called your initial amount or your starting amount or your initial value, starting value. And then we've got this relationship between two consecutive terms. So R, remember, is your common ratio, and D is your common difference. So in the case of financial maths, R is circling too many things. I'm going to be circling the whole page in a sec. Let's just get rid of that. R is calculated, or capital R, I should say, your common ratio is calculated by this. So little r is your annual interest rate, and P is your compounding periods. So just make sure whenever you write down a formula, so if you do write this again into your bound book, and instead of just having this page, just make sure you take note that R is your annual interest rate, not the monthly interest rate or anything like that. If you do use the monthly interest rate, then you don't require P. So it's probably just good to be consistent. Keep it as R, and P is your compounding periods per year. All right, so just using the same formula instead of just playing around. Some people are pretty confident with these formulas and understand how they work. Even if it's explained to you how it works, sometimes it can be a little bit confusing. So just keeping it consistent with this formula is probably ideal. And D is your additional repayments. All right, if we're looking at reducing balance loans, so very similar. Right, we've got our principal value. We've also got R, but this time it's going to be minus your repayments. Okay, so we're adding the repayments for investments and taking away for reducing balance loans. So if you think about it, if you've got an investment, your money obviously is growing in value. So it's an example of growth. Reducing balance loan is an example of decay, all right, because it's going down. You would hope your loan would go down. All right, so R is still calculated the same way, and lowercase r and P, it's still your annual interest rate, and P is your number of compounding periods. Now, that's your recurrence relations. You do need to understand how they work. We'll look at annuities in a separate video. You don't have rules for these because it's too hard. You can't substitute in a value. Yeah, you need to do the different iterations. So we're just going to be focusing on recurrence relations, basically. All right, now when you're doing it into your calculator, remember it's very important as to what is positive and what is negative. So here we go, Mr. Rich Guy down the bottom, he's investing some money. So he's investing $100,000 into the bank. So into your financial solver, it has to be negative. So it's going out of his pocket and into the bank. So it's negative 100,000, and I can see he's making repayments there. So it's also negative because those repayments are going to the bank, not to him. Then if we've got a loan, so the best example of this would be a mortgage. So let's say we took a loan for $500,000. Because that money is coming to you, it's positive. All right, so your principal value or your present value is positive. But your repayments, because they go back to the bank, are negative. So it's very important that you remember that. All right, and this page here is just looking at annuities and perpetuities, so don't worry too much about that. We'll cover that in a separate video. All right, I'm going to go back to this recurrence relation page because we might refer to that later. Let me just get my notes. All right, so let's have a look at a few of these questions. I might do every single one of them. I haven't made a plan. Whether I do them all or not, we'll soon see. So Jane has already saved $300,000 and plans to add an extra $50,000 per year to an investment account. Immediately after the interest payment is calculated, the account pays interest of 5.2% per annum, compounding annually. All right, so when I do a maths problem, it's always a good idea to read it all through once, okay, and then read it again. Usually that first time would be during reading time if you were doing it in a test or an exam situation, and you're just thinking about it. Things like she's saved $300,000, has already saved $300,000 and plans to add an extra $50,000 per year to an investment. All right, so we've got an investment here. And the account is paying interest of 5.2% compounding annually. So it's very important to know what the compounding period is, because if it's something other than annually, you really need to think about which formula to use. I mean, it's the same formula, but it's just slightly different to the very first one you were introduced to. So they're the key parts we need. So recognizing that it's an investment. Now, let's say you're still just starting out, getting used to investments. It's probably a good idea to have either this here, if we're doing a recurrence relation, or looking at this part here for the investments. All right, so understanding how it goes into the calculator or how to do the recurrence relation. All right, you really need to have your notes before you do questions to get used to using them. All right, so state the initial value. So she saved 300,000. So our initial value is, whoops, I was about to write 500,000, 300,000. State the amount added each year. Now you're adding a value, so it's got to be positive. Even if it was repayments, it would still be positive. So just make sure you think of it in the context of the problem. So if I always use the example of if you were losing weight, so let's say you weighed 100 kilos and you lost 5 kilos, you don't say, oh, I lost negative 5 kilos. It's still 5 kilos. So in a loan, you're making repayments of $5. All right, it's not negative $5. It doesn't make sense. All right, but this is an investment, so let's move on. All right, determine the value of the growth multiplier R. So this growth multiplier is your common ratio, which you've done plenty of times, hopefully before. Hopefully this isn't your starting point. And let's just, for ease of seeing things a little bit easier, the ease of seeing things a bit easier. All right, there we go. All right, there's our R. So 1 plus your annual interest rate over 100 times P. So in this case, P is just 1 because that's how many compounding periods we have. It's just yearly. All right, so I'm going to write that down. R is equal to 1 plus R over 100 times P. And R is equal to, so that's our annual interest rate, 5.2, and P is equal to 1. Sorry about that. So it's probably a good idea to, whenever you use formulas, to write them down. All right, especially if you struggle, just write them down, and it just allows you to think. All right, otherwise you're kind of holding that formula in your head and you might stuff it up. So just copy it down and take your time. It's better to take your time and get something right than to rush and get it wrong. All right, so I can just do that one without a calculator, but you can do that easily on your calculator. So our growth multiplier R is 1.052. Model this investment using the recurrence relation. All right, so remember your recurrence relation, the only thing that changes is the principal, your value of R, and your value of D. All right, so we've got V0 is equal to 300,000. And then Vn plus 1 is equal to R, which we calculated in the previous question, times VN, you don't have to put the times in, but I'm just going to do it, plus your repayments, so 50,000. All right, so there's your recurrence relation. You can put V0 after that, that's fine, doesn't really matter. You don't need to put a comma, I mean, as long as you've got everything there. You can put a comma there if you like. All right, moving on to the next one. So just for the sake of this, I was going to say movie, this video being short, I'm going to highlight things as we go. So Sarah invests, so we're looking at an investment, and it's very important to know whether it's an investment or a loan, okay, because remember we calculate it differently. 1,500 at 7.3% per annum, compounding daily. All right, so now we've got something other than a yearly compounding period. She plans to add an extra $4 to investment each day immediately after interest is calculated. Let VN be the value of the investment after N days. So it's probably a good idea to highlight that too, so you're consistent with what letter you're using. And we're going to write down the recurrence relation. So it's probably good. I don't have to flick back to my notes. It's written up here in the previous question. So I'm just going to refer to that. So she's invested 1,500, and remember that stays the same. The only thing that changes is our R and our D. So our R value, I'm going to put it in brackets, 1 plus our annual interest rate is 7.3 over 100 times the compounding periods. So the number of days in a year is 365. If you feel you're going to forget that, remember it's in your notes. All right, guys, you can have your notes for everything. It's super duper. All right, times VN plus 4. So $4 per day. All right, so let's just tidy this up. I can't do that in my head, so I'm going to have to do it on the calculator. All right, so we've got 1 plus, and then shift divide, we'll get up our little fraction, 7.3 over 100. Now it doesn't always cooperate when I do it. There we go, 365. So that's our value of R, 1.0002 times Vn plus 4. All right, that's your recurrence relation. Beautiful. All right, next question. Rachel invests. So we're still looking at investment, $24,000, 6% per annum, compounding monthly. She plans to add an extra $500 each month. Let VN, so we're looking at the letter V, the investment after N months. Write down the recurrence relation to model Rachel's investment and determine the value of the investment after 6 months. Round your answer to the nearest cent. All right, so we've got 2 parts to this question. So let's write the recurrence relation first. So we've got V0 equals 24,000. All right, so the starting value. Vn plus 1 is equal to, and now we're going to calculate R. So 1 plus our interest rate, which is 6 over 100 times the number of compounding periods. So it's monthly, so 12 months in a year. And then we're going to add on her extra repayments, which is $500. All right, so I'm going to do that on my calculator. 1 plus 6 over 100 times 12, 1.005. All right, and we want to find after 6 months. So we want V6. So what we can do on the calculator, so we've done quite a few of these before. So you can keep pressing enter on your calculator, or you can put it in your sequence screen, or, and I don't think I've actually done this on the calculator yet, you can use Finance Solver. So I might show you all 3 ways for this question. So first of all, on your calculator, let's use the recurrence relation. So 1.005 times our initial value plus 500. All right, so that's V1. And then I'm going to do the same. Oh, actually I have to do this every time. You can't keep pressing enter for this because it just won't work. Plus 500. So I'd actually have to keep doing that. And yeah, that's too time consuming. I should have realized that. So let's go into sequence where it will work. All right, so let's put in, don't really need to delete that because we can just use what's already there. 0.5 times AN plus 500. And the initial value was 24,000. All right, and that's a good thing about your calculator. There we go. All right, so V6 and, oh, you're going to stop? Sorry, I must have just pressed it too many times. Go back up. All right, so look at, I haven't got it to too many decimal places, so I do need to click on it to see all those decimal places down the bottom. So don't think it ends at 6, 7, and then the decimal point. Just press on it and you can see the number here. So 2776681. All right, so you can do it on your sequence screen. What I will probably end up doing is using Financial Solver. So if we just go there, if it's going to work for me, come on. All right, oh, good. I was about to flip. All right, so let me just clear. All right, so you come up with your little menu. So mostly we're just going to be using compound interest. So N is how many compounding periods there are. So that's 6. All right, so we wanted it after 6 months. So just 6. Here is your annual interest rate, which is also 6. It's going to let me press it in. Now, this is where you need to be aware, is it negative or is it positive? So this is an investment. So when you're unsure, you just go here and let's go down to investment. All right, it's going to be negative, all right, because it goes to the bank, and your payments are also going to be negative because it's going to the bank. All right, so get the calculator back up. All right, so where did my work go for? Oh, things have gone missing. Oh well, doesn't really matter. I thought, wait. All right, so we're going to do negative, don't mind me, that thing's just deleted off my screen. Negative 24,000 because it's going to the bank, and then she's making extra payments, so they're also going to be negative because remember they're also going to the bank. Doesn't mean you've lost money or anything like that because clearly it's still your money, but it's just going out of your pocket. All right, and important to note down here, and it does say if you go to help what it is, so the number of installment periods per year, so, and then here's the compounding periods, which I've never seen them different. So what are we doing monthly? So it's going to be 12, well, they're both going to be 12, so they're usually the same. All right, and we want the future value, so we just go press on there. All right, and we've got the same answer. Super duper. All right, so you could use sequences. Financial Solver, I think, is probably a little bit better because we don't have to actually calculate. For this question here, it does say to do the recurrence relation, but if it didn't ask to do the recurrence relation, you can go straight to the Financial Solver, whereas for the sequence, you would have to do the recurrence relation before you could work out that part of the question. All right, moving along. A compound interest investment, so it's an investment again, we are coming to loans, is modeled by the recurrence relation. Yeah, and it's very important to do this question. Remember, they're all different. So if you have pause and think, oh yeah, I'm super duper good at these questions, I don't need to watch anymore, they're not repeating the same skills. So just be aware of that. This is the first question where we've been given the recurrence relation. So what is the principle of this investment? Oh, it's easy. So these types of questions are usually the first ones you're asked in an exam, all right, just to ease you in and make it easy for you. So that should be like a gimme mark. How much is added to the principal each quarter? Here we go. That's what we're adding, $2,000. I actually didn't read the question, did I? Just highlighted a bunch of things. Quarterly, there we go. Use your calculator to determine the balance of the investment After 3 quarterly payments have been made, round your answer. All right, so again, we've got the recurrence relation here. Now, if I was to use Financial Solver, I would actually have to work out what the interest rate is because it hasn't given it to me. And I could easily do that by using this formula. So remember, it just comes from this. And then you just substitute in. So our R value is 1.025. Our interest rate, so lowercase r is what we're solving for, and it's 100 times 4 because it's quarterly. All right, 4 quarters in a year. So you could just use solve and solve for R if you like, and then use Financial Solver. But because we've got the recurrence relation, I'd probably use sequence, to be honest. Come on. Okay. All right, so let's just put a 2 in there. And what are we doing? 2,000. And our starting value is 20,000. All right, so what do we got? 3 quarterly repayments. So again, we can't see all the decimal places, so press on it so you can see them. And we need to round it to 2 decimal places. So 27689. And let's just go back. 06. Now, you can't round that. Don't round that to 5 cents. All right, every cent counts. Has to stay as 6 cents. Just making sure I've written that question right. 3 quarterly payments. All right, and then D, plot it. Now, you should be able to plot this from your calculator. Is it going to work for me? No, so I can see my y-axis only goes up to 52, so I need to actually change my window. Actually, let's just go zoom quick and maybe, is it going to work? No. I always just change the window manually. All right, so we're going to 3 quarters. So our minimum value is 0. I always go 1 below. Actually, we can leave it as 0 to 10, doesn't really matter. But our y does have to be higher. So I might do that up to 50,000. Oh, let me, come on. Now we should be able to see it. All right, so you can see the points there. And you can just go to zoom, sorry, on the graph. Go to analysis, wrong button, analysis trace. And then you get your little cursor and you can move along. Oh, it does work. It just doesn't like it when my laptop is folded over. So there we go. All right, so you can see the values there. What I might do is just go out a little bit more. So let's go to 50 and I might go up to 100,000 just so you can see what the graph looks like. It looks like it's linear, but it's not actually linear. All right, so don't make the mistake of thinking it's linear. So it is slightly curved. All right, so again, you can go to analysis trace and then just get those values like that. Yeah, so there it is plotted. So if you had to plot this, you can it's not a hard one to plot. All right, you can see the values there. I'm not going to do that because let's make this video not too long. It's already 24 minutes. All right, reducing balance loan. So writing a recurrence relation. So remember, going back here, previous page, here's your reducing balance loans. So principal, there's your recurrence relation. So you just need to do the principal amount and your R, just make sure you're subtracting your common difference. Whereas for the investment, you are adding. All right, just going to fold it back. All right, so we're going to be writing a recurrence relation to model a loan of $3,500 borrowed at a rate of 4.8% per annum, compounding monthly with payments of $280. So, and we're using VN. Okay, so V0, you've always got to write V0 for a recurrence relation. So that's our initial amount. It is positive. It's always positive. Vn plus 1. All right, so we've got our R, our capital R, remember, is calculated by 1 plus your annual interest rate, which is 4.8, over 100 times P, your number of compounding periods, which is 12, times Vn. And this time we're subtracting because it's a loan. Okay, so if we go back, see, minus, and before when we're doing the investment, we're adding. So main difference between the two. All right, so let's just tidy this part up. Get my calc. All right, so 1 plus 4.8 over 100 times 12, 1.004 times Vn minus 280. And there's your recurrence relation. All right, next question. Consider a loan of $235,000 borrowed at 3.65% per annum, compounding daily with payments of $150 per day. And we're using V again. It's not always going to be V. All right, so for question A, we're going to write the recurrence relation. So V0, our starting value, 235,000. And then our value of R, 1 plus our annual interest rate, 3.65 over 100 times 365. And then we're making repayments of $150. All right, I know I should be able to do this in my head, but I feel like I'm going to miss a decimal place if I did. So I'm just going to do it on the calculator. All right, so 3.65. Actually, I think it's going to be 1.1. But anyway. Times 365. 1.0001. Definitely got too many decimal places. All right, 150. Oops. Missed something very important. All right, the Vn minus 150. All right, so don't forget you don't have to put the times in. I do just because I think it looks a bit, you know what you're doing. If you put it in. All right, question B, find the value of the loan after 3 days. So on your calculator, you can just keep doing 3 iterations. I'm going to just use Finance Solver so we can have a bit of practice of that. So you don't have to go to clear all, you can just go clear page and it'll just clear all the values to start fresh. So we're doing after 3 days, so N is 3. I is always your annual interest rate, which is 3.65. P is your principal, or in here it says future value, same thing, 2, 3. Oh. Now, let me just go here. All right, so we're doing a loan. So remember, your principal value is positive and your payments are negative. So because the money is coming to you, it's positive, but when you make repayments, they do go back to the bank. So it is negative. What was I doing? Putting it into the calculator. That's why I went to that other page. All right, so it's positive here. All right, our payments are negative because it's going back to the bank. And get the calculator working. Future value is what we're going to be calculating, and it is daily, so we need to do 365 here and 365. All right, so our future value, so we don't worry about that negative, okay, because we only want the positive value. So 234,620, 234,620. And 46. All right, so make sure you always do 2 decimal places. All right, nearest cent, 2 decimal places. All right, another one. Reducing balance loan can be modeled by the recurrence relation. All right, so we're using Vn. So it's given us a recurrence relation this time. So state the initial balance. So that's going to be $5,000. State the repayments. So 865. determine the annual interest rate. So they've given us capital R. So if we want lowercase r, our annual interest rate, we're going to use the formula for R, capital R, and substitute everything in. So R is 1.01. Lowercase r is what we're calculating, and P is months, so 100 times 12. You can do that by hand, but we can also use solve. So I'm just going to use solve because most of you will probably use solve. 1.01 equals 1 plus, then we go shift, and just leave it as X. We don't need to find R. Just make sure when you do your answer. Alright, so R is equal to 12%. It's a very, very high interest rate. Find the balance of the loan after 2 payments have been made. Alright, so we only have to make 2 payments, so you could probably just do it on this screen. So and I'm just going to use recursion. So 1.01 times 5,000 minus 865. Alright, so that's after 1 month. And then we do the same thing again. So 1.01 times the previous amount, 4185, minus 865. So 3361.85. And you could do that in Financial Solver, and here I'm just doing it on here because it's a short one to easily show you 2 payments. So 336185, 3361.85. All right, and we'll stop there. So the next video will cover annuities and perpetuities because there's quite a few questions there, but I'm so glad it just went over 30 minutes. All right, bye guys.